This is question 11. We're told figure 2 shows a sketch of the curve h with equation y is equal to 3 over x plus 4, where x cannot be equal to 0. In part A, we're asked to give the coordinates of the point where h crosses the x-axis. The question carries 1 mark. H will cross the x-axis when y is equal to 0. So we'll have 0 is equal to 3 over x plus 4. If I subtract 4 from both sides, we've got minus 4 is equal to 3 over x. Dividing both sides by minus 4 and multiplying both sides by x, x will be equal to minus 3/4. So the point now of intersection will be minus 3/4, 0. In part B, we're asked to give the equations of the asymptotes to h. So let's start off now with the vertical asymptote. The vertical asymptote will not have moved. It's going to be now the y-axis or the line x is equal to 0. If we consider the horizontal asymptote, we can see now that this is going to be the line y is equal to 4. Y can never be equal to 4 as x can never be equal to 0. Or, if you like, we can see this now as a graph transformation of 4 units in the positive y direction. So we'll have now x is equal to 0. That's going to be the vertical one, and then we'll have y is equal to 4, which is going to be the horizontal asymptote. In part C, we're asked to find an equation for the normal to h at the point P, which has coordinates minus 3, 3. The question carries 5 marks. The normal is just a straight line. What we need for a straight line is a gradient and a point that it goes through. We've already got a point that it goes through, but we need a gradient. The first thing I'm going to do is find the gradient of the tangent to the curve at the point P. We can do that by using dy by dx. dy by dx is the gradient function. So if I just rewrite y, I'm going to write y is equal to 3x to the power of minus 1 plus 4. So dy by dx, the gradient function, so this is going to give me the gradient of the tangent, multiplying down by the power, we'll have minus 3x to the power of minus 2. I'm going to differentiate a constant which will give me 0. So we can say the gradient function dy by dx, I'm just going to rewrite this as minus 3 over x squared. If we consider the point P, we can say now at P, dy by dx, the gradient of the tangent will be minus 3 over minus 3, which we need to square. If we consider this now, that's going to give me the value of minus 1/3. I'm going to call that m1. m1, the gradient of the tangent, is minus 1/3. Therefore, m2, the gradient of the normal, is going to be positive 3. As m1 multiplied by m2 will be equal to minus 1 if perpendicular. Remember, the tangent is perpendicular to the normal. So what I've done is found the gradient of the tangent at the point P. I've then found the negative reciprocal, as the normal will have now a gradient that is going to be at right angles or perpendicular. Therefore, we just find the negative reciprocal. So let's consider what we have. We have P, which is minus 3, 3. We have m2, which is the gradient of the normal. That's 3. All I need to do is sub this into the equation of a straight line. I'm going to use y minus y1 is equal to m, the gradient, x minus x1. You can, of course, use y is equal to mx plus c. Y minus 3 is equal to 3, then we'll have x minus minus 3, which is x plus 3. In part C, it says find an equation. This is an equation. I can leave it in this form if I want. I'm going to write it in the form y is equal to mx plus c, but when we're asked for an equation, this would be perfectly fine. If I expand the brackets, I'll have 3x plus 9 plus another 3, so we can say y is equal to 3x plus 12. Or, if you like, 3x minus y plus 12 is equal to 0, and that's in the form ax plus by plus c is equal to 0. We're now told this normal crosses the x-axis at A and the y-axis at B. In part D, for 3 marks, we're asked to find the line segment, or the length of the line segment AB, giving our answer as a surd. Okay, so let's just sketch this up. We've got 3x plus 12. Now if we just think about what we have here, we have a positive gradient. It's going to cross the x-axis when y is equal to 0. So if we consider when y is equal to 0, 3x plus 12 will be equal to 0. Subtracting 12 and dividing by 3, we can see now that the x-coordinate will be minus 4. So we're going to have this point right here, and that's going to be minus 4, 0. If we consider where it crosses the y-axis, that's where x is going to be equal to 0, so y will be equal to 0 plus 12. That's going to give us the point somewhere up here, and that will be 0, 12. It doesn't matter that this isn't massively accurate. All I've done is gone ahead and looked now at that line. It's entirely up to you on how you want to do that. All we're interested in now is finding the length. The length uses the distance formula, and the distance formula, d, is given as the square root of x1 minus x2, which we need to square, added to the quantity y1 minus y2, which we need to square. So we can say that AB, the length of the line segment, will be the square root. I'm going to do 0 minus minus 4. So if we put that in, 0 minus minus 4, which I'm going to square. And then I'm going to add to that now 12 minus 0, which I need to square. So if we consider what we're going to have AB will be equal to the square root. This is going to give me 4. 4 squared is 16. This is going to give me 144. So we can say at this stage that's 144. So I've got AB is going to be equal to the root of 160. They want this in a simplified surd form. I can say that this is root 16 times by root 10. So we can say now that AB will be equal to 4 root 10. So 4 root 10 is the length, simply using the distance formula. It's asked me to give my answer as a surd. It didn't ask me to simplify. I'm going to simplify and write it as 4 root 10.